Hey guys, so today we're looking at chapter 3 in statistics, introduction to statistics. So we'll be looking at how is describing data using numerical measures works, and also look at some probability, right? So let's go into it, right? So before I go into depth with probability, let me talk about descriptive statistics, right? So quick recap. Okay. Statistics, right? Okay. As the word says, descriptive statistic, what does this mean? You're describing data using statistical models. Okay. Now question is, what are those models that I'm talking about? Okay, so let's do just a content on that. Okay, firstly, you've got types of data, right? Now your data is divided into two. It's either you have qualitative data or you've got quantitative data. Now let me make a summary of what I'm talking about. You've got a variable. What is a variable? A variable is anything actually of character. Okay, so your data, it's either you've got qualitative data or you've got quantitative data, right? Now if you talk about qualitative data, what is qualitative data? This is a type of data which is referred as being non-numeric, right? Numerical, that's qualitative data, right? Like for example, the names of cars. You've got your Mercedes, you've got your BMW, you've got your Toyota, right? All these are just names, they're non-numeric. If you're talking about quantitative data now, you're referring to numeric data. Numerical data, right? Now under these types of data, we've got something which is referred as measurement of scales. How many measurement of scales do we have? We've got 4. Okay, and if your data is referred as being qualitative data, now the measurement scales that this type of data can take, it's either nominal or ordinal scale. If it's quantitative, it's either interval scale or ratio scale. Okay, so you've got nominal and ordinal. Under quantitative data, it's either interval or ratio. Okay, so to go into depth about this, you'll then need to go to and search on my notes on what is the difference between these two things. But just to give you guys a brief breakdown on what's happening under measurement scales. Under measurement scales is, if your data is qualitative data, then it's either you're dealing with nominal scale or ordinal scale, right? So let's define these two quickly. Nominal or ordinal scale, right? Okay, if you're talking about nominal scale, this is a type of data which can be put in a categorical form. Okay, categorical form, right? Okay, this one, ordinal. If your data is referred as being ordinal, what do you mean? You mean that, number one, firstly, it will have characteristics that a nominal has and have one on its own, which differentiate it with nominal. Okay, firstly, it also has, your data can be put in categorical form. Okay, number two, there is what is known as natural order. Right. Okay, now let me make examples here. If you're talking about a type of data, firstly, it has to be qualitative data. For it to be nominal, it has to be in a categorical form. For example, how books in a library are being packed in shelves, that's nominal, right? So you find that books, they just put books. They're not like in a form where this book, it's a must that it needs to be here. No, it's being put in a nice categorical form. Now in your wardrobe, how you place your jeans, how you place your t-shirts, you putting it in a nice place in a categorical form. Like for example, you say my jeans, they here, and my t-shirts, I'll put them here. That is a nominal scale. Number two, before it becomes a nominal scale, it needs to be qualitative data. Make sure of that. If it's ordinal, let me make an example of something which is it falls under ordinal scale. Now this is a type of data which is qualitative, that's fine, and also there is natural order. For example, the number of days we have, right? We've got Monday, Tuesday, Wednesday, Thursday, and Friday, Saturday, and Sunday, right? Now, if you tend to look at these things, these days, they're being put in a categorical form, starting from Monday up until Sunday. So there is also a natural order here. You'll never find Wednesday being the first day of the week, right? There is natural order. Yes. Now let's look at interval. Let's look at interval and ratio. And ratio. Now this falls under quantitative data, right? Hence it's numerical. Okay, quantitative data. Right. Now, if it falls under quantitative data, now what is the difference between interval and ratio? Okay. Now, interval difference makes sense, right? Okay, let me just put this here. Difference makes sense, right? Now, this is one characteristic that defines a quantitative data. If it falls under interval, the difference between values need to make sense, right? Like temperature, right? That's the example of it. If you tend to look at temperature, number one, temperature is of numerical, right? So it's quantitative data. So the difference between the temperature today and tomorrow, if it makes sense, then it's interval. Okay, now let's look at ratio. Ratio is also quantitative data. Now, if you tend to look at ratio as a measurement scale, firstly, your data needs to be quantitative. For it to be ratio, zero, number zero, hence it's numerical. Number zero need to make sense. Right. Okay. Now, if you understand all these things, you then need to also understand now the fact that under quantitative data, there are two types of data. It's either you've got raw data or group data. Let me talk about that. So we've got what is known as raw data. Raw data. Now, raw data is referred as being discrete, right? Discrete data. discrete data, right? Now, if you're talking about discrete data, you're talking about countable data. Countable data, right? Like, for example, this type of data, 5, 4, 3, 10, 11, right? These are numbers which are referred as being countable, and they are of discrete, right? Okay, then you've got what is known as, so under discrete data, I mean, you also need to understand that if you're being asked to calculate the mean, this is the formula you use, xi divided by n, right? This is the summation of every numerical value you have divided by the total of them. Okay, like for instance, in this case, you'll say 5 plus 4 plus 3 plus 10 plus 11 divided by 5. Okay, then if you're being asked, then if this is the mean, this is the mean, right? Obviously, if you're being asked to find the mean, which is x bar, right, you then need to also understand there is what is known as standard deviation. If you're being asked to find the standard deviation in raw data like this, you need to also understand there are formulas you use. We know that standard deviation, which is also referred as being the error, standard error, is just the square root of this, right? Okay, so you can use the calculator, right? Again, the note on how to find the standard deviation under raw data and how to find the mean under raw data, they are on Moodle. Okay, so you can go to Moodle and find the notes there, but this is just a quick recap. So you also have now what is known as group data, which is what I'm interested in the most. Now, group data comes from raw data, right? How do you see group data? Group data can be presented in a form of a frequency table. Frequency table, right? Where a frequency table will have your class limits. Okay, let me make an example of a frequency table. Okay, you've got class limits, you also have your frequency. Like for instance, if you say from 0 to 5, 5 to 10, 10 to 15, right? 15 till 20. Okay, these are class limits. Remember, there's a difference between class limits and class boundary, right? The formula for class boundary, is, you say class limits, right? Class limits minus, if you're looking for a lower class boundary. Class limit, which is this one here, because you're looking for a lower one, right? Class limits minus the distance between your diagonals, right, divided by 2, right? And the number you'll get here is your lower class boundary, right? If you're looking for your upper class boundary, then you need to add, right? You say class limits plus the difference between the diagonals divided by 2. Why am I emphasizing this? It's because you guys need to understand now that if you're being asked, if you in chapter where you're talking about descriptive statistics, you need to understand that if you're being asked, now this is a tip, if you are given a question based on group data, where they referring to a percentage, you need to use percentiles. Hence per se, so there's a percentage involved, right? Percentiles. Now the formula for percentiles is Pi is equals to Li plus C of Ni times I divided by 100 minus F less all divided by Fi, right? Now the reason I'm emphasizing that class limits is different than class boundaries, because this Li here, it's for class boundary, not class limit, right? Okay, so just to go back to this, so if you've got your frequency now, 8, 10, 11, 12, right? Firstly, if you're being asked under group data, the shape of your data, you need to look at your frequency. If your frequency is increasing, it keeps on increasing, so that means you'll have a right. If it keeps on increasing, so that means your highest peak will be on your right. So that means you're dealing with negatively skewed data. But if your highest peak, so you look at your highest frequency, that's your highest peak. So if your highest peak is towards your left, that means you're dealing with positively skewed. But if it's in the middle, then you're dealing with what is referred as being bell-shaped, right? So again, if you're being asked to find the mean or the standard deviation under group data, use the calculator. You'll find the note on Moodle, okay? Okay, now let's move, guys. Let's move. Then you also have what is known as CV. What is this? Coefficient variation, right? Coefficient variation, right? Now, as the word says, variation, so it tends to check the relation between two units, between two things of different units, okay? So this checks the relation of two variables of different units. And the formula for it is CV is equals to S divided by X bar times 100, right? Okay. Now, if you understand this, now let's talk the language of probability. Probability. What is probability? Probability is chance. Is a chance of something of interest happening, right? Now, probability is the value between 0 and 1. I mean, if that's the case, that means a percentage is also a probability, because a percentage is a value between 0 and 1, okay? Now, let's talk about what is set, right? A set is a collection of all possible outcomes, right? A collection of all possible outcomes, okay? So what is a sample space, right? Sample space. What is a sample space? A sample space is the set, right? The set of possible outcomes. Okay, is a set of all possible outcomes. Okay, now I want to make something clear here. If you're talking about all possible outcomes, these outcomes comes of random experiments, okay? Random experiments. right? Now these random experiments, so for these outcomes to occur, there is a chance for these random experiments to occur, which is, a chance is the probability, okay? So now for example, if you're tossing a coin, right? A coin has a sample space, just one coin. The sample space of tossing just one coin is either a head or a tail, okay? Right. So let me just try squeeze this here. Let's talk about the sample point, right? Sample point is every individual in the, let me just say every outcome in the inner sample space. Sample space, right? Okay. Now, for example, we made an example of tossing a coin, right? Example, one coin. One coin, tossing one coin. Okay. Now, I always ask this to people that if, let's say you're tossing a coin, right? Now, how would you know that your sample space, if tossing one coin, is just getting a head or a tail? Now, people always tend to say, okay, if I take my coin from my pocket, then I toss it for the first time, I'll either get a head or a tail. If then that's one outcome. Then I toss it again, it's either I get it's either I get a head or a tail. So there are only two possible outcomes out of tossing just one coin. It's either you're getting a head or a tail. But my question is, what if you don't know? What if you don't have a coin, right? What if you don't have a coin? How would you know that your total, the total number of sample point you'll have in your sample space is how many? Now, to answer that, you need to understand these things. Combination and permutation. Right. So hold that thought. Now, we're talking about rules, right? They are counting formula rules. Counting formula rules, right? It's either you've got what is known as additional rule, right? Additional rule, or you've got multiplication rule. Rule, right? Like the word says, additional rule, so you're adding, right? Multiplication rule, there's multiplication involved. So let's say you've got two experiments, okay? You've got experiment 1 and experiment 2. Here you also have the same experiment and experiment 2, right? If your experiments can be done simultaneously, right, you use multiplication rule. If the question asks you how many ways, how many ways, right? How many ways can you do this, right? How many ways can you interchange your pair of jeans and t-shirts, right? Okay. If you can do things simultaneously, you need to understand that you're dealing with multiplication rule. But if these events, this random experiment can't be done simultaneously, then you need to use additional rule, right? Okay. Like for example, you'll use additional rule if, let's say, you're being asked how many ways can you wear your pair of shoes, right? Like for instance, you can't wear your pair of sneakers and your formal shoes at the same day, right? So if that's the case, if I ask you how many ways can you wear your pair of shoes, then you need to understand you need to use additional rule. If you can do, if how many ways if your experiments can be done simultaneously, then you need to understand you use multiplication rule. So now let's go back to this question here of tossing a coin. How do I know that my sample space of tossing one coin is either head or a tail, right? How do I know? The first thing I ask myself, do I want order? If tossing my coin, is there order or there's no order? If there's no order, it's combination rule. If there's order, it's permutation rule, right? So if tossing just one coin, the question is, do I want my coin to flip on a head first, then flip on a tail? Now, I mean, that's obvious. I wouldn't know. So there is no order to flipping a coin, just one coin. So I'll use combination rule to find my sample space of just tossing just one coin. How do I do that? Now, I say N combination R, right? Again, you use your calculator, okay? How many sides does a coin have? It's 2. Combination, how many sides will my coin land on? It's 1, right? So my sample space is 2, right? So that's why, so every time before you label your sample space, you need to know how many points, how many sample points are you going to have on your sample space. So it's better to calculate first before you label it, right? So now, for instance, if I know it's 2 and I've drawn now only 2 outcomes, so I know I'm done, okay? Now, question is, if I've got 2 coins, what is my sample space? Again, this is 1 coin. Let's take another coin. 2, 1, right? The answer is 2, right? So that means my sample space of tossing 2 coins is 4, right? Because this is for the first coin, this is for the second coin. So I've got now 4. In my sample space, I need to have 4 sample points. Which are those? It's either you get a head, a tail head, or a head tail, or a tail, right? Okay. So now you see I first calculated before I listed my sample space. Okay, so this is important. Now my question is, to get 4, did I add 2 plus 2 or did I say 2 times 2? Right. So to answer that, it comes back to counting formula. Now my question to you now, can you flip 2 coins at once? And the answer is yes, right? So if the answer is yes, so that means you can do your experiments simultaneously. If you can do your experiments simultaneously, you use multiplication rule. Okay, there are 2 special events, right? Event, right? So these 2 special events, it's either your event is possible or impossible. If your event is possible, the probability of its happening is 1. If your event is impossible, right, the probability of it not happening is 0. Okay. Now let's go to these events now. Now you've got what is known as a simple event, right? Simple event. Simple event or single event. This is the event that has only one element. For instance, tossing one coin. Right? One element, for example, just tossing off one coin, right? Your sample space is head or a tail. What is the probability of getting a head when tossing a coin? The probability of getting a head is, so this is, firstly, this is a possible event because you can take a coin and get a head or a tail. So it's a possible event. It's a doable event, okay? So the probability of getting a head is just half, right? Right? This is the number of all the possible outcomes, right? And there's only one head in a coin. Okay, so it's a half. Again, the probability of getting a tail is also a half. Okay, then we move to, now some people will ask you, when do you use these signs? There are these signs. When do you use these signs? Okay, now that's simple. You use these signs if you're dealing with a compound events. There's something called compound events. These are events that consist of more than one element. Okay, more than one element. Right. Okay, like for instance, what is the probability of you passing stats if you failed Maths 130? Right? So you see here, you're dealing with more than one element. You're dealing with someone who's, okay, you've done your stats 130, and what is the probability now of you passing your Maths 130? So you've got two elements. It can be even more elements. Okay? Okay, so when do you use this? When do you use, this is referred as, this is the union, right? This is the union. This is, okay, this is referred as addition, right? Union, so it brings things together, right? Okay, this is referred as the intersection. Intersection, right? This is referred as being conditional. Right. Now this is referred as multiplication, right? Is multiplication. Okay, let me write this nice. Let me, intersection. So it intersects, okay? But before we go into this, let me explain this diagram. Venn diagrams, right? Right, A, B, right? This is a Venn diagram, and these two events again are referred as being mutually exclusive. They are disjoint, okay? And you've got independent events, right? You've got independent events, right? Now, if you're dealing with independent events, you need to understand that the probability of their intersection is just probability of A multiplied by B, right? Mutually exclusive events, the intersection of A intersect B is equals to 0. So it's an empty set, okay? As you can see here, they're disjoint, okay? And so that means that the probability of A union B is just probability of A plus probability of B minus 0, which is the intersection. Okay, now I always get questions like, when do you use these three signs? Okay, now to answer that, when do you use this, right? If the question, if the probability question has these words, or, right, at least, right, at least, what else, okay, now, or at least, yeah, then when do you use this one, intersection one? If the probability question has these words, right, both right? And, but, okay. Yeah. And when do you use this one now? This is known as conditional, right? Conditional probability. Conditional. So they're conditions now. When do you use these ones? Again, okay, let me use a clean slide. When do you use this one? If the probability question again has these words, if statement, or it is given, or it is known. It is known, right? Then you'll need to understand then I need to use conditional probability, okay? Which is also part of something that we'll talk about just now, which is Bayes' theorem. Okay, Bayes' theorem. Okay, again, like I've mentioned here that this is addition, this is multiplication. If you don't understand how does these words go about, you'll use these words like here you see it's additional rule, so this means that you've got two or more events which can't be done simultaneously. So if events can't be done simultaneously, you use additional rule. We know that, so that's why we'll use union if to find the probability of A and B, right? Or B, I mean. Under multiplication rule, you've got multiplication sign. This means that to find if you're being asked the probability of events which can happen simultaneously, then you'll use intersection, right? Hence multiplication rule. Okay. So let's close off with Bayes' theorem. Bayes' theorem. What is Bayes' theorem? Bayes' theorem is conditional probability. Probability of A given B, right, is equals to the probability of A intersect B, okay, all over the probability of B, okay. So this always comes here. This is the intersection, okay. This here, okay, so this here is the intersection between A and B, right, which can be found in this formula here. Right? Because where are we taking this from? From here, probability of A, total probability, right? There's something referred as total probability. Is the probability of A intersect B plus the probability of A intersect not B. Okay. So to get this, again, if you don't have this, but you have this, you can find this, right? So obviously this will come from the total probability again. Total probability again, right? So, I mean, the probability of B can be equal to the probability of A intersect B plus the probability of not A intersect B. Right. So yeah, this is just the background of what's happening in chapter 3, which is probability. I did a recap on descriptive statistics. So yeah, this is just a background. If you want more information on this, you can go to the Moodle page. Notes will be there of everything we've talked about, and also exercises. You do those exercises, I tell you, you'll get a straight A. And yeah, thank you.